All right, hello everybody. This is Miss Pi with another video. This one we are covering the area and law of sines. With this unit, we're going to see a lot of different types of triangles. So far, we've covered right triangles, but there's a lot of triangles that are not right triangles. You've got acute triangles, obtuse triangles, equilateral triangles, all sorts of different types of triangles that are not right triangles. We will come to find that all triangles follow the same basic patterns no matter what their dimensions or sizes. First of all, the angle C here, the opposite side is also labeled C. Angle A, opposite side is A. Angle B, opposite side is side B. Whoops, I moved my shape and I wanted to draw something. I wanted to label this as side B, and side B equals 6. All right. With every triangle, no matter what the shape and size, you can always draw a straight line down from one angle to the opposite side, and you get a right triangle. Okay, and then to find the height of this, we could use our trig ratios to find the height. All right, so far, let's work through this problem, and I will show how we came up with our area and law of sine formulas. So with this triangle, we have angle A is 50 degrees, angle B is 63 degrees, and side B is 6 units. And then what other sides or angle measures can we determine just from this information? Well, we can also figure out what our angle C is, just because we know that 180 degrees is how much all three angles will add up together. So if we do 180 minus 50 degrees plus 63, notice I'm adding these two together before I subtract it from 180. When I do that, I find the third angle, and I find that that third angle is equal to 67 degrees. Okay? All right, so now there's not any other information I can find, but I can draw this straight line down and find the height, and then I want to use the height and sine of angle B to find side A. Okay, so we're using that height, or excuse me, I missed one. So use sine of angle A to find H. So my sine function, let's see, here's angle A. So I have sine of 50 degrees, and that's going to equal my opposite, which is my height, over my hypotenuse. And in this case, here's my right triangle, so the hypotenuse is 6. So height over 6. And then when I solve for H, I multiply both sides by 6. And I find that H is equal to, let's put it in the calculator. I know you guys don't have calculators, but you know how to plug it in. So I get what I end up getting is 4.596. If I round to 2 decimal places, it ended up being 4.60. Okay. And then for my next one, use height and the sine of angle B to find side A. So this time I'm finding this. I've already found the height. Now I want to find side A. So I'm going to do sine, and I know my angle B is 63 degrees. Okay. This time we are doing this angle. I know my height. Okay, so my opposite side, the height is 4.6. And then I'm going to divide it by my hypotenuse, and in this case it's side A. Okay, now this time I will multiply by A and divide by sine of 63. So I'm going to multiply by a. That'll get rid of my denominator of an a with an a in it. And then notice I will, on this side, I'll end up with a times sine 63. Well, if I divide both sides by sine of 63, then I can have a all by itself. So what ends up happening is I'll have a, and that'll equal 4.6 divided by sine of 63. Okay, and I plug that all in my calculator. Let's see, what do I get? I get 5.159, okay, which if I round to 2 decimal places is 5.16. All right, so what measurements are left to be found in the triangle, and how can these dimensions be determined? So let's erase what I have so far. So far I have A, I can check that off. I have my angle C, I use right here is angle C. This is side A, and I have my height. Let me put the height back up there. That's a straight line, just pretend it's a straight line. And I have height. Now I want to find, what do I want to find? Let's see. Oh, sorry. So I really don't have anything else on here to find, unless I want to, did I find side C? Now, let's find side C. How would I do this? Okay. Right now, that's what I've got. I have my height and my A and my B, side A, and my height. Well, I can find, if I break my C down into 2 different parts, so this part here and then this part here, I can find both parts and then just add them together. Okay? If I want to do that, I can use this angle. This would be my adjacent side, my A. That's the adjacent side, and the hypotenuse. So I need cosine. So I'd use cosine. And I will tell you, I have not calculated this out, so I'm not going to do the calculations. I'll just show you how to set it up. So because I am working with my adjacent hypotenuse, I'm going to use cosine and then 63 degrees. And that's going to equal my adjacent side C divided by my A value of 5.16. Okay, I multiply both sides by 5.16, and then I can find C1, part of my C value. Okay, notice I'm labeling this C1 here. All right, and then I can do the same thing but use 50 degrees and 6 for my hypotenuse, and I can find this side over here, C2. All right, so I've managed to find every measure. I will manage to find every measurement of my sides and all my angles based on my height. Well, I can do that. I can find the height of any triangle, no matter what shape it is. As long as it's a triangle, I can find the height. And what you're going to soon realize, we could do like 10 more problems and we'll realize that every triangle has a proportion, and what happens with your proportions for the law of sines is that your sides, if you set up a proportion of your side measurement and then the sine of the angle and set each of those proportions up, they will all equal each other. Okay? So this will be invaluable to use if you only know maybe 1 or 2 sides and 1 or 2 angles. Okay. Also, I know that my area formula is 1/2 base times height, and when I have all my triangles and I find the heights, eventually I will figure out very quickly that my height ends up getting factored out, and I just have these proportions where I need to know the 2 of the sides, and an angle measurement that's in between the 2 sides. If I have that information, then I can find my area using these formulas here. Okay. So let's look at two problems. I have this triangle. I have a side of 5, a side of 4, and a angle of 36. So my formula is going to be 1/2 my side B, which is 5, times my side C, which is 4, times my sine, excuse me, of angle A and and angle A is equal to 36 degrees. Okay, I will plug all that in the calculator, and the calculator does all the work for me, and it tells me that my answer is going to be 5.88 feet squared. See, it's area base times height. So yeah, squared. All right. So, excuse me, I just found the area of a triangle that is not a right triangle. Okay. That works the same no matter whether it's an acute or an obtuse triangle. If I do it again, I can find 1/2 side times the 19, side C, and then times 26, which is side A, times sine of 103, which is angle B. I plug that all in the calculator. The calculator does all the work for me. And I find, excuse me, that the area is going to be 240.67 centimeters. Notice I'm rounding my area to 2 decimal places. Okay. All right, so that was the area. And then to find missing sines or angles of a measurement, I'm going to use my law of sine, set up my proportions. So right here I'll have this fraction, and then I'm looking for side C. I could also find angle A and side A if I wanted to, but this time they don't really care. So let's set up our proportions. So I have 10.4 divided by sine of 79. So that equal to side C divided by sine of 40. Okay, most of the time we want to cross multiply and divide. I will tell you, you don't have to always do that. If you look at this, if you just multiply everything by sine of 40 degrees, you get side C all on its own, okay? So when you multiply everything out, you get C is equal to, let's see, what did the calculator say? He said side C is equal to 6.81. Notice that, and that's in meters, notice that this long length here is 10.4, and this side C, if you look at it, it looks proportionally smaller, and the answer is slightly smaller, okay? I will tell you, most of the worksheets, they do a good job of making sure everything is proportional. All right, so number 4 is same thing. I set up my proportions, sine A. Oh, this time we're looking for an angle measurement. Let me give myself some more space. And I want to work through all this. So I have side 20A is 22.4 over sine A. The reason why I want to work through this again is because it is a little bit more complicated when you're looking for the angles. And that's proportional to side B of 30.8 divided by sine of 97 degrees, excuse me. I'm going to cross multiply and divide. I ended up with sine A is equal to the proportion of 22.4 times sine of 97, and then divided by 30.8. If I cross multiply and divide, that's what I end up getting. Now remember with our inverse sines, when you do inverse trig functions, you're switching the angle and the ratio. Okay? So when you do that, this whole thing gets put in here, and then I will find the angle of angle A. When I plug all that into the calculator, I find that my angle is 46.2 degrees. I know I went through that very quickly. We'll practice some more on Monday when you come to class. I hope you enjoyed this. You might want to keep this handy to refer back to the steps and processes, particularly when you're looking for an angle measurement. It is a little bit more complicated. You need to set up your ratios first, then do the inverse of the inverse sine. Put your ratio in here, plug it into the calculator, and that will tell you your angle measurement. All right, I hope you enjoy this. Have a good day. See you Monday.